our second aspect of today's lecture, which because of the difficulty and the timetable, we have to split into two. And unfortunately, the trend may also continue for a while. But next week, we are going to have a morning section, and then we'll complete with an afternoon session. But we are not starting at 7. We may start around 9 o'clock. So, I'll re-echo it again before we leave the class. So we are all once again welcome back to the session. When we were leaving, our last discussion was on math skills. So let me quickly ask for those who are around, how many forms of math scale representation did I discuss or talk about? Anybody can raise their hand and then respond. Okay, I see Manarama.
So the types we looked at the word or the statement scale, the representative fraction or ratio scale, then the graphic or the linear scale. Thank you, sir.
All right, that's great. That's our point. So there were 3 forms of math scale representation. The common one are the second and the third. The verbal one usually is used in narrative and in essay expression, but they are hardly used against the math. Maybe probably because they are statements and they are longer than the RF, the linear. And then secondly, each of these methods have their challenges. So my next exercise to you, note it down, is that for each of these math scale representation forms we've spoken of, go and do a research on the advantages and disadvantages, what some will call merit and demerit of every system. And your minimum number of points you should gather for each is 3, minimum. Maximum 5, minimum 3. So another research and assignment I'm giving to you. I hope you are getting me clear. So we mentioned the word scale, or what we call statement scale. Hello. In the meantime, Steve, are you on? 7. Edu. Emmanuel Santa, you have your hand up. Emmanuel Santa, your hand is up. But he's not aware. Okay, we'll continue. Emmanuel Santa, your hand is up.
Yeah, my device was worrying me. So you said you gave us an assignment. I just wanted clarification on that. Advantages and disadvantages of. I didn't hear the other side well. Thank you.
Yes, as I'm giving you work to do. Do it. It's going to be your note. You are not going to submit, but I can ask you at any time as a form of assessment to do that. It can also even appear in your exam. We've spoken about 3 forms of math scale representation. I said go and find the advantages and disadvantages of each one of them. So when you take word scale, which is also called statement scale, or verbal skill. What are the advantages in using a word skill? Find a minimum of 3 and a maximum of 5. So if you don't get anything at all, your research, you should be able to conclude on 3 advantages and 3 disadvantages of each system. There are 3 in all: word or statement or verbal, RF or fractional skill, and then graphic or linear skill. Samuel,
Thank you,
did you
sir.
say?
Yes, sir.
Mm-hmm.
Good evening, sir.
Good evening.
Please, I hope we will find them in the material.
Do you
I mean,
understand
the
research?
handout.
Do you understand research?
Sir,
Dami, do you understand research?
yeah. But I want to know whether we will find them in the material.
Why do you want to ask me that?
No, the handout that we are buying.
And I'm asking you a question, you are not answering. So why do you want to ask me that?
Oh, just to make the research easier
Sami, you don't
and
want to learn. Sami, you don't want to learn. Me, in my class, if you don't want to learn, you will fail.
Oh, I want to learn. I really want to know. I just want to know.
I am telling you. You students that are coming up, a lot of you now, you don't want to do any research, don't want to put any work, you just want to be fed. Me, if I'm teaching you, you will not get that from me.
Okay, sir.
I don't know if you have a platform where you can contact some of the people who have finished ahead of you and ask them whether I'm doing surveying and cartography or I'm doing mass media interpretation. It's not designed for you to feel, but if you don't want to work your way around it, you will have to support. So research is still research. After all, the word there is research. So from what you know to what you don't know, comb in, take in, look there for the information. One thing I always advise, I don't know if you were on the platform on Friday, but me, one of the things that I do is, if I even give you a material, it is not 100% guaranteed that you're going to go. It isn't that the material is not good, but I want you to be attentive in class and I want you to be grounded in what is being said so that a material acts as a backup. So when you have the material, it's good. It's very, very good. But the material is not 100% guaranteed for your A. Mm-hmm. You have to come in, you have to listen in, you have to stay online. Now I have the habit that when they get the material, no, I can baby at that. It will be hot. That is my class. It is not to say that the material does not have the stuff. Yes, there are a lot of things there. But you have to also be in class to listen to what I say, explanation, among other things. It's not all of them that probably you may find in the material. Does that mean? So you do the research. Why?
Okay, sir.
Whatever you find and come across, it's all part of your research. You know where you are, you know the information you have. But this one is a common place, whether it's a book or it's not a book, or you can easily find it. So my point is, we are teaching the 21st century way, and 21st century way research is part. That's why I told those who we met on Friday that the 4 weeks is woefully inadequate for whatever we are supposed to. But the understanding we had is that we have to facilitate, not teach. So some of the things we'll highlight there, try to explain, then we'll push the rest, go and fill in, and come back. But I think it's all within 4 weeks. You know, the one who goes and fill in or does the work will be okay. But if you go and sleep or put it aside and you let other things rather take priority, you realize the 4 weeks is up. You cannot blame anybody. Anyway, that is by the side. So the assignment, let me clear it again. We are looking for the advantages and disadvantages of each of the map scale representations. The first one we discussed was the word or statement skill. Probably, let me pull it up. The word or statement skill. The second one that we had there was RF. RF skill, representative fraction skill. That is the one that we had there. And the third was the graphic or linear skill. All right. So that's it. I'm trying to share of my slides. Yeah, I'll go out and just relaunch. All right, so I hope you got it right. I was just trying to bring the slide that we used the last time. First to the math skills. All right. Now another thing that we need to smartly learn through about this math skill is that there are forms of representation. So the next thing that we have to do is that we need to be able to convert from one form to the other. We need to be able to convert from one form to the other. We'll be doing that alongside a few of the works as we go along, but I'll not be saying so much there. So that was to, I wouldn't say that I'm not teaching, neither would I say it is not a research. So add that one also to your, how do we convert from one form of math scale representation? Did you hear that one? Hello, did you hear me?
Yes, sir.
This is gone
Yes.
quiet. Okay. So we were talking about conventional math skills, sorry, the last time. So you've noted your assignment. This one is not for submission. But go and do it. Note it, put it in your diary, mark it, and go and do it. Find merits and demerits of each of these three math skill presentation forms. If you don't get anything at all, you have three for merit, three for demerit. But if you do a good research, you get more than three. And do it for all the three. Hello.
Hi.
Yes, sir.
All right.
Yes, sir.
You knock that down. Good. Now, if you didn't carry a few pieces of paper, I'm forcing you to go and do one now. To get a piece of paper, get a pen. I'm going to pose a question online, but I'll not show you on the screen. I'm going to dictate, so you have to write it, and then you're going to discuss it. 10 minutes on the math skills, then I'll move on to my main issues for the second session. When we meet next week, I'll come back again on some other aspect of math skills, and I'll continue my lecture. I'll do that kind of thing for about 3 of the engagements. Then I would have concluded issues on math skills. So beside the assignment, get a paper, get a pen. I'm going to pose a question. And then it's on conversion, but I've told you that we should be able to move from one to the other. One to the other. So I'm going to pick them, but there are 3. When you do the presentation, there are 3 ways of converting from one form to the other. So I'll handle one after the other. So that is it. So I want to believe you heard me. Get yourself a paper or a jotter, if you like, in relation to math reading interpretation. More jotter so that you can make some small notes. A mix of issues. I want to look at it like a tutorial stroke lecture. Dynamics. So are we ready? Do you have our paper and our pen? Okay. So we pick it up. It's not going to be on the screen, so I hope nobody's going to tell me he's not seeing it on the screen. You listen and then you write this down. Hello.
Hi.
Good. So
Hi.
they are RF skills, and I'm going to convert them to a word skill. They are RF skills, and I'm going to convert them. No, let me do the other way around. They are word skills, and I'm going to convert them to RF. They are word skills, and I'm going to convert them to RF. RF is representative fraction. So example number 1. Example number 1, and this is the statement. What is the corresponding RF skill? What is the corresponding RF skill? For a word skill stated as, what is the corresponding RF skill? For a word skill stated as 2 centimeters on the map. 2 centimeters on the map represents 100 meters on the ground. What is, I'm going over the question again. So that's the first example. Then I have a second one too. So first example, what is the corresponding RF scale for a wedge scale stated as 2 centimeters on the map represent 100 meters on the ground? So do you have your papers with you?
Yes, sir.
Thank
Yes,
you
sir.
very much. Good. All right. So the first thing is, what did I say was the definition of map scale? So you write it. Map scale is equal to. Map scale is equal to. Then you are going to write it like a numerator and a denominator. So the numerator should be map scale is equal to map distance. That should be in the numerator. Over ground distance. Map distance over ground distance. That's the definition of map scale. Map scale is equal to map distance divided by ground distance. That's the first one. Have you written that?
Yes, please.
Yes, please.
Okay. So with the word case, they said that 2 centimeters on the map represent 100 meters on the ground. Let's use the equation to write the same map scale. What will be the literal representation of map scale according to the formula? So it will be map scale is equal to 2 cm as a numerator divided by 100 m. Is that what we had? Is that what we had?
Yes, sir.
Yes, doc.
Okay.
Yes, sir.
So the formula should be map scale is equal to 2 cm divided by 100 m. Okay. Now, that is the statement scale you have used the formula to write. It is a statement scale you have used the formula to write. At that level, it is okay. But now we are casting our mind back to what we said about the RF scale. It will seem as if you have a ratio, which is looking like 2 divided by 100. But then there is a problem. I don't know who has recognized the problem. But the formula that you've written it is correct, 2 cm divided by 100 m. But we are going for RF, and RF is the map scale in the form of a ratio. Now, if I'm looking at the expression and I want to consider it as a ratio, Lawrence, you have your hand up. That was a mistake.
So I wanted to talk about the problem. You said there
What's
was
the
a problem. Per the discussion that we had, RF scales has to be, or they have to be in the same unit. And for this, we don't have the same unit. We have centimeters and meters.
Bravo. Great. That's it. So you see that the formula will tell you that mass scale is equal to 2 cm over 100 m. If you look at it in terms of ratios, you look at if it is 2 divided by 100. But the problem is that the top one is centimeters, the down one is meters. So in terms of ratio, it has failed, or we have to do something about it before we can say we have well represented the ratio. It cannot be cm at the top and m at the bottom. So either they are all cm, cm, or mm. Please, are you with me? I'm forcing you to try and
Yes,
do
sir.
both a mental and a pictorial activity. That's why I'm not putting anything on the screen. Listen and let's work a lot. And subsequent engagement, we're going to ask a lot, so you'll get used to it. But if only you are partaking and writing on paper, whatever that we are talking about, you should be able to find an easy ground for a quick one. So thank you very much. So we continue. So because the top is 2 cm and the down is 100 m, we cannot say we have put it in the ratio concept, because the ratio is an expression, it's a relationship, looking at the map to the ground, but there should be common units to both of them. So it's two things, either we convert the cm to m, or we're going to convert the m to cm. My rule is always to convert the higher unit to the lower. What do I mean by higher unit? If you recall, when we were in primary school and other places in mathematics, we used to do some scale of conversion practice in math when we are doing small mental math. We used to say that 10 millimeters is equal to 1 centimeter, then 10 centimeter is equal to 1 decimeter, then 10 decimeter is equal to 1 meter, then 10 meters. Do you remember?
Yes, we
sir.
do.
Yes, sir.
Now, from that narrative and that concept, that theory, you will see that 10 millimeters is 1 centimeter, and another 10 centimeters is 1 decimeter. Then 10 decimeter is 1 meter. So from that ratio conversion, 100 centimeters will give you 1 meter. 100 centimeters is equivalent to 1 meter. You can turn that relationship around and say that 1 meter is equal to 100 centimeters. Or if you want to write that with a symbol, you can write it as 100 cm is equal to 1 m. Or 1 m is equal to 100 cm. Have you heard of this statement before, or are you conversant with it?
We are good, sir.
Yes, sir.
Good.
Yes, sir.
So this is the rule. You will see clearly that when you are changing from centimeter to meter, between the two of them, there are 100 divisions. But it depends on how you apply it. Between the centimeter and the meter, you see that we call it the scale of conversion. It's 100 divisions. Because the other side is 1, the other side is 100. So it's 100 divisions. But this is the rule. If what you are seeking is already in meters and you are going to centimeters, you multiply by the 100. The value that you have already in meters, you will multiply by 100 to get the centimeters. But if the value you are dealing with is already in centimeters and you want to get the meter equivalent, you divide by 100. Why is it so? Meter and centimeter, meter is higher than centimeter. They are all units of measure, but I'm talking about scaling. The same way kilometer is higher than meters. So anytime you are doing a conversion from a higher unit scale to a lower one, you multiply by the scale of division in that relationship. So between centimeter and meter, the scale of division is 100. Scale of division is 100 parts. But because I intend to work from meters to centimeter, I'll be multiplying by 100. But if my analysis is saying that from centimeter to meter, I'll have to divide my figure coming from the centimeter by 100. Is this principle clear?
Yes, sir. Very clear, sir.
Good. Another one happens between meter and kilometer. Meter and kilometer. In fact, by what we have done, you can even find between millimeter and meter. But for now, I'll not go to that side. But you can see that it is possible. If we go for millimeter meter, the scale of division becomes 1,000. But when it's centimeter meter, the scale of division is 100. In the same manner, between kilometer and meter, the scale of division is 1,000. Between meter and kilometer, the scale of division is 1,000. And what is the relationship? 1,000 meters is equal to 1 kilometer. 1,000 meters is equal to 1 kilometer. There too, like I said, between the meter and the kilometer is 1,000 divisions, scale divisions. So if your calculation is that I have a kilometer and I want to find meter, kilometer is higher than meter in terms of the scale unit. And therefore, whatever your value in kilometers, you will multiply by 1,000 to get meters. But if the analysis is seeking for kilometer, and what you have data on is meters, you are moving from a lower rank to a higher rank, you would divide. Always note, it's consistent everywhere. You have to take note. So, centimeter, meter, 100 divisions. Meter, kilometer, 1,000 divisions. While you move, we'll show whether you're going to multiply by the 1,000 or divide. Now, from these two connections that I've just spoken of, centimeter to meter, meter to kilometer, I am going to deduce the third relationship, which is now going to look at centimeter to kilometer. Centimeter to kilometer. We've done centimeter to meter. We've done meter to kilometer and vice versa. Now we want centimeter all the way to kilometer. What will be the scale of division? From what I discussed or said earlier, centimeter to meter is 100. Meter to kilometer is 1,000. So from centimeter to kilometer, it's simply 100 multiplied by the 1,000. So what is the rule? 100,000 cm is equivalent to 1 km. Between centimeter and kilometer, there are 100,000 divisions. But if you have information already in kilometer and you want to find its equivalent in centimeter, you will multiply by the 100,000. Elijah, you have your hand up. Yes, Elijah. Okay. So, if we want to convert from centimeter to kilometer, the centimeter is smaller in terms of the scale unit compared to kilometer. Kilometer is big. So when you are moving from small scale unit to a higher scale unit, you would divide by the unit of division or the scale division. So for instance, if I have 2 centimeters and I want to find its equivalent in kilometers, I will take the 2 and divide by 100,000 units. Please declare.
Yes, sir.
Okay, so now quickly let's go to our story and finish our first one in the basket and see how we proceed from there. Good. So now I'm trying to share a slide and see if my calculation can be done. Usually it's difficult writing on screen through this medium, but I'll see how best. So let me see what I can get as my drawing to, let me say this one. Okay. So this is my expression of mass scale, MS, and the MS should be equal to 2 cm over 100 m. Now I have to change either the cm to m or the m here. But I told you my rule is always to go for the big coming to the small so that I can multiply. So it means it's the meter that has to change. Now, what is the statement about? 1 meter is equivalent to 100 cm. Therefore, 100 meters is more, less, divide. And you see clearly that the 100 meters will have to be computed as 100 times 100. Get the centimeters. Get the centimeters. Of course, I'm writing the expression on the side here. We are saying that 1 meter is equivalent to 100 cm. So if 1 meter is equal to 100 centimeters, what will be 100 m? 100 meters to be more. So if more or less divide. So you see that when you are looking at the 100, to be equivalent to between these two, if more, less divide. And here there's a more because the 100 is bigger than the 1. So it becomes 100, which is the more at the top, divided by 1, which is the less, times another 100 coming from here. So what happens to my 100 m? The expression now translates to 2 cm over 100 times another 100. The zeros will go to 4 from the 2. So 1 and then 4 zeros. Then the unit is no more m, it is cm. Are we there?
Yes, we are.
Good. So when you do this, now you have created a condition that matches what a proper ratio is. Because the top is cm, the down is also cm. Now, because they are the same unit, they cancel out, or you can take them off. And when you take them off, what is the expression that you see? You are going to get 2 divided by 10,000. Good. At this stage, you have done well, and the ratio is not, it's is well structured. Let me put it that way. I'm careful about my words. I don't want to say it's wrong, but I'll say it's well structured because now you've succeeded in bringing all of them into the common unit. But there's also another property of RF scale. Your numerator, which will eventually be part of the statement 1:2, cannot be any value apart from 1. I want to note it down. Write it somewhere. This one is not part of the material. It's what I'm teaching you. So these are all the things I talk about when you are in lecture. Not in the material. The calculation will be seen in the material, everything, but the condition as I'm stating that the numerator cannot be any value apart from 1. You will not find it. You can find that and apply, but you will not find it as a statement written for you to read or come across and read. So notice. In RF, we want to establish ratio. We've done that. But the second rule is saying that you cannot leave your final answer with the numerator as any number apart from 1. What that means is that though we have here 2 over 10,000, we cannot leave this as our answer and say the scale is 2:10,000. That would be wrong. We have to let the 2 change its form to become 1. How do we do that? We divide the 2 here by 2, and we divide the base here, which is 100,000, by another 2. Note, it is still the mass scale, which is equal to 2 over 10,000. But the rule is saying that we cannot keep it at 2 at the top here. It has to be 1. So how do I make the 2 at the top turn into 1? You divide that by 2. It becomes 2 divided by 2, and you get 1. It's an expression, so you cannot do it for only the top and leave it that way. If you do it for only the numerator and leave it that way, you have changed the expression. You've changed the ratio. Your answer is wrong. So what will happen for the sake of explanation? Let me write the expression down so that we see what is happening there for the sake of the explanation. So I'll write it this way. I'll go and divide the top by 2. So it becomes something like 2 divided by 2, the top alone. Then I'll go to the down and I write it as 10,000. But of course, if you are used to mathematics and you are not, as it were, frightened by it, you don't need to necessarily write the statement. You can do your processing and still go ahead. So the 2 at the top has been divided by 2. Why? I wanted to turn it into 1. So I've deliberately divided that 1 by 2. If you apply the action to the numerator, you should say to the denominator. When you do that, the expression will remain unchanged. If you forget to do that, you have introduced a new expression. So divide the top by 2, divide the down by 2. What do we get? The top will turn to 1 because 2 divided by 2 is 1. Then what happens to the down? You have 10,000 divided by 2, and that will give us 5,000.
5,000.
So what is the RS scale now? I am in common unit. My top is 1. That's the last part of the action. So my scale is 1 is to 5,000. And that should be our answer. Are you all there? Is it all clear?
Yes, sir.
Okay.
Yes, sir.
So it would have been wrong if at this stage here we have stopped and written our RF as 2 is to 10,000. In terms of the ratio, it's not wrong, but in terms of the RF scale definition, the top cannot but remain as only 1. So whatever figure is there, the smart way is divide that same figure to the top and divide to the bottom. So for instance, if it wasn't 2 and it was 5 or 3, all that I have to do is, if it is 3, I divide the top by 3, then I go down there to divide the down by also 3. At times, your answer will come with some decimal for the down one. Don't worry, it's not wrong. But it will be wrong if you don't ensure that the numerator is 1. So, landing, I'm just giving you an example. You can get an RF scale that's stated like this: 1 is to 1, 5, 3.7. There's nothing wrong with it. It's correct. You are seeing a decimal here, 0.7, but it's correct because here is 1. And I say 1 part on the map represents 153.7 parts on the ground. Correct. Something wrong. But usually we don't like it like it doesn't make it look nice. That's why we always request what data point or value that are generally okay. All right. So we've seen where we began from, 2 cm over 100. You have to change to common unit. What are the skills of conversion? That those I've explained to you. You need to always revise yourself about that, commit to memory. Then, after you've established common units and you have the expression, you examine again to see if the top is 1. If it is 1, bingo. If it is not, divide it by the number there and do the same application to the denominator. If you do that, you have not changed the expression, but you have succeeded in changing it from one form to another. But the value stays. Good. So let's be thinking about this. Maybe by the time I meet you the next time, I'll ask you what's your answer. So you write it down as quickly as you can, like we did for this one. What is the RF? What is the corresponding RF scale? What is the corresponding RF scale? What is the corresponding RF scale? For a statement scale stated as, for a statement scale stated as 4 centimeters on the map represents 5 kilometers. 4 centimeters on the map represents 5 kilometers. Please, are we clear?
Yes, please.
Yes, we are.
Thank you very much. So let's proceed. In our next lecture, when I come. Stevie, are you on the line? Rev Steve, Edu.
Yes,
It's not
yes,
there.
sir. Please, I'm here.
Okay. Hey, Steve. Because I'm going to give you work, you don't want to respond. Okay. So when we come in next week, you will be the first one I'm going to ask you what you got as your answer. So note it down. so that we are on the common page as to what the answer is. Good. So we proceed with our discussion. We want to look at conventional symbols. But before we look at conventional symbols, we are going to talk about map symbols. As you saw in my introduction and with respect to the maps, one of the essential components I did mention was the legend. Now, what the legend does for us in our maps is to help us understand the various symbols used in the map, what they stand for. We may call it the key, the same thing, whether it's legend or key. So that is very key for us understanding what is contained, because our work is map reading, then it is also map interpretation. So whatever that is put on paper as a representation, we should have an idea of what it represents. See if your hand is up.
Yeah, Doc, I was here, so I've been listening.
Okay. And you are very slow in listening to what I said and react. Anyway, so we proceed. So my point is that whatever we take as a map, there are representations of the map. If it's a road, maybe a line is doing the trick. That line may have a color or something. When you go to the legend, it is that line with that color in the legend that you want to know what it represents. So with map reading and interpretation, knowledge on map symbols and conventional signs are key and critical. You cannot do otherwise. So what then are map symbols and what are conventional signs? In fact, conventional signs are map symbols, but their nature and characteristics is that they have been used worldwide. In fact, they have been accepted, that's the word, accepted for use worldwide for representing certain features. For example, if you are doing cartography and map making analysis, contours represent the earth, contours talk to the soil, contours talk to the ground. So by convention, it has been accepted that contour lines should usually be brown. Good. So we need to have a clear understanding of those issues. See, if you still have your hand up.
Sorry, Doc.
So we make progress. All right. So conventional signs, like I said, they are map symbols. So who are map symbols? Any understanding there is? Then how do we come to talk of conventional signs after getting used to map symbols? Like I said, conventional signs are map symbols. So once we know what map symbols are, the only let's say variation between the two connections is in the widely accessible use of those symbols for the various representations they are called out. Like I said, contours are usually brown. Area liable to flood, you will find some shrubs with some dashes of line, or in blue because it's talking to water. Talking to water. Railway line, you may see it in black. Okay, so how the symbol looks like and has been accepted and used worldwide is what gives it that profile of the conventional sign. So quickly, let me go through what map symbols are, and then I'm going to give you yet another activity to consider and to look at. You are not submitting, but you have to get it done so that you see how your feedback on what you got can help us place it in context what we lecture. So that is with it. So let me put this one down briefly, and I'm coming back with shortly something that will be done within some 10 minutes, map symbol. And it will also be part of the slides that we'll be giving or putting on the page. So usually when in lecture, you can connect. Like I said, you have to be making your own notes or you have to be jotting down some key things to help you connect faster. Refer to some of trying to share the slide. Okay, you just hold on. Okay. So, but here, everybody should stay online. I'll just connect. People, I don't know. I thought of what's happening. I'm trying to get a slide and it's not allowed. But I've closed the browser a number of times. Give it a number of times. Let me try some other tricks. Just another fraction. All right, so the great technology teaches. Let's see how we proceed from where we left. All right, so we are looking at map symbols, but the main idea is about the use of conventional signs. And then the next discussion would have been angles and bearings. So we are looking at map symbols or conventional signs. And each of the representation on this slide is a symbol. It's a symbol. So what is a map symbol? A map symbol is basically simple drawing. Letters, shortened words, or color shapes or areas used in maps to convey information. Maps give us a lot of information, and there's so much room. There's not so much room for labels, meaning that it's not everything that we will attempt to be writing. Then you say this one is river, then you write river, maybe together with its name. Then you say this one is forest. Even in the same map, there are about 2 or 3 different forests. They have their names. You are going to write all of them: forest, Echan forest, Ajua forest. You can see how lengthy the text and then the issues can be. So map symbols always offers us an opportunity to make representations on the map, which may not necessarily have to draw up or take up so much space. And that is one of the key advantages of the use of map symbols in maps. So we use map symbols to save space and make the map easier to read. A map will always a map. And their role is to explain the meaning of the symbols used. It is therefore not necessary to learn all map symbols because you cannot do that. So you make use of a few, and that is why conventional symbols come in that are commonly used, and now they have been packaged. Then others will be treated as specifics. As we meet them, then we find information about them. It is even possible for one to draw a map and use map symbols of his or own kind. Provide a key that explains what the symbol stands for and to add it to the map. So you just say that you can come up with your own ingenious way of representing things. But it depends on whether the map you are going to produce eventually going to stay with you alone or you want to send it outside for others to make use of it. In that case, you have to revisit it and get the issues properly. Most map symbols are conventional signs as they are understood by everyone around the world. So that is the departing point. What makes conventional signs different from map symbols? Or we can see that conventional signs are a subset of the bigger picture called map symbol. So there are a few of them here, and as we begin to deal with maps, we may come across them as well. And so these are more point representation symbols. Others such as this may be area representation of symbols, like area labels, like a pond, or a lake representation usually takes the form of an area. Then we have some examples there in here. It may look small, forgive me, because it was a bigger document I've squeezed into the slide. But the idea typically is to help us appreciate some templates that are around. So we have this query page, general one, sand page, other page. But when we move on to the other side, we have what we call a motorway. Some of the design are not Ghana based anyway. They are foreign. But the idea is to give us what we mean by symbols, the signs of representation, the various writings that go with it. So that's the idea for this. So don't mind that it's looking very small or tiny. But it's actually a huge document and a complex. All right. So there is another one. We can also zoom into this. And basically, that's the idea for the map symbol. So when we talk of conventional signs, we are looking at symbol representation that is known worldwide or is generally used worldwide for certain representation. That is very, very key about conventional signs. The types. Conventional signs appear in different forms. And examples of some of these are the line symbols. That is the picture is a line represented like roads, like the outline. Just the outline of buildings, the line. But when you go all the way around, it becomes a polygon. So these are the issues that come up when it comes to map symbols and conventional signs. So we need to build it up. And if we don't know much at all, at least about 20 25 conventional map symbols, we should be aware of them. Should be aware of them. So that is also something we have to think through and work on. But so that is it. So map symbols are drawings, anything representative. You can use color, whatever, all those things. But when it comes to conventional signs, then we are looking at a selection of some of these symbols worldwide acclaimed, understood, used, and we also follow by applying them to our maps generally. That is worth noting and very critical for us to understand. We can also look at the classification of conventional signs. The classification of conventional signs as either physiographic, communication or root signs or symbols, settlement symbols, or functional symbols. That in classifying so I've mentioned them, do the reading around them, and then you get to know what they stand for. Then we can appreciate each of them. Those are called physiographic. What do they do? What do they stand for? Those are called communication or root symbols. What are their nature and what do they do? Those are called settlement symbols. What are their roles and what are their duties? And those are called functional symbols. What are their roles? Okay, so having noted that well, let's pick the pieces from online and then plug it in. If the material gets to our end too, and there are some of them in there, we take note of that. So that is how we will proceed. And that is how we bring our discussion on the conventional science to map symbols to good. Are there any questions? Good. So since there are no questions, I will proceed then to our next issues on board what we want to do next after this conventional science debate. We want to now look at the other aspects herein we are calling the second part of the material, angles and bearings. Angles and bearings. And you have to listen generally, but here to will not take much time. In fact, in the ideal case, most often some of these things are handled for us under surveying and cartography. But I don't know the program whether we all go through both survey and cartography in the map reading. So we still try to bring it on board even when you are treating the courses on their own. See how we deal with angles and bearings. So my next discussion is going to be on angles and bearings. This part of our material is going to be on angles and bearings. Most often than not, when you are dealing with map reading, at times you want to know the location of one feature away from the other. And to be able to describe orientation in space, alignment in space, among others, we need to look at bearing, which is talking about direction or orientation. Yet, as we begin to try and understand bearing, we will see that there is a need to also understand angles. So most cases, certainly, when we are discussing, we don't go straight for bearing because we want to be monocle to relate one town to another in terms of direction. That is all. But we try to pick the fundamentals that feed into the explanation of what we want to do under bearing. So we look at what an angle is. When we speak of an angle, then we are talking of the arc between two intersecting. So, like I said, an angle is the measurement of the arc between two intersecting lines. We also call it two intersecting directions. So you see that the arc is the turn between two lines. If you are doing mathematics, and then at this point, let me give you a chance to also open a fresh page similar to what we use for our map scale calculation. So let me duplicate this one. And then let me send it to the last page. All right. So let me take this thing. So basically, what we are saying is that if you have two lines, that's how math interprets that. If you have two lines, one is going this way, the other is going that way. Sorry. Good. So if you have two lines, one is coming this way, one is going that way, then there's a tendency of an arc defined between these two lines. Good. So this is one example of an angle. There are two lines. You can call this one 1, you can call this one 2. Once they meet, then an angle is formed between them. There's also another angle that is formed from here. And mathematics will tell us that when you add the two angles, you get 360. So simply put, an angle is the measurement of the arc, and by the arc we mean this action, this turning action from this line all the way to that. The space it travels is what we are calling the angle. The same is the action also here. So that is it. However, you see that when I was speaking about my definition, I said two intersecting lines. I didn't talk about the plane that is intersecting these two. So when we begin to talk about angles, then you see that there can be types of angles. If, as I've posed on the screen you are watching, we consider this whole background of the slide as a plane. When we say a plane, we are just talking about a sheet. Then the way my drawing has been captured, it means these two angles, one let me call it alpha, the other one let me call it beta or theta. What that means is that alpha or theta may be called a vertical angle. Why? Because I've used a sheet or a plane to track the action of the two. So because the plane I've given to you is vertical, then we'll say that is a vertical angle. But think of it in another way, where this same slide I'm showing to you via the computer screen, via your phone, is now placed on a table. If it is placed on the table, our alpha and our theta will just represent horizontal angles. Do you agree with me? So when you draw two lines on a blackboard, that is by a wall, between the two lines, there's an angle issue. That angle will be called vertical angle. But when you draw two lines joining over a table, which is flat from above, we would say you are dealing with horizontal angle. So always the qualification to the angles must be placed well in perspective. Then we move on to bearing. What then is bearing? Bearings are orientations. Bearings are directions. Bearings are alignments. So how do we get it defined? If you watch my explanation with respect to the angle, I was talking about two lines meeting, two lines meeting, two lines meeting. So in the angle construct, clearly two lines are meeting, 1 and 2. But when we go to bearing, there is a variation and a twist, and that is where I want you to be careful about it. In fact, in general sense, a bearing is direction. But in technical sense, a bearing is the angle a line makes with the reference meridian. Plenty powerful, yeah. But you have to take it cool. In defining this angle, for instance, my alpha here, when I wanted to talk about alpha, this one is alpha. When I want to talk about alpha, there are two lines I'm looking at, line 1 and line 2, joining here. And this is also critical. The lines must intersect. So that defines alpha. We talk about the types and everything. How about if I want to talk about direction? In terms of direction, there are two lines again involved, line 1 and line 2. So in the case of bearing, we don't deal with two lines. We can only deal with one line at a time. So bearing defines itself as the angle. Yes, when you go to angle, there are two lines involved. So how is bearing making use of angle to show direction? One of the angle is put as a start reference. Sorry, one of the lines is put as a start reference. So for instance, suppose I want to find the bearing of this line. Let me use a different color. Let me increase. So you are looking for the bearing of this line. I'm just using arrow so that we can see it well. This line is here and I want the bearing of this line. If I'm only going to use this angle to explain my bearing of this direction, then this angle is talking to this other reference one. And that reference one will be called the zero mark, the start mark. So that is how we define bearing. The angle a line makes with a reference meridian. So the other part of my definition is meridian. When you say meridian, surveying map reading is the north direction. So north direction, there are three in surveying. We have what we call magnetic north, we have what we call geographic north, and we have what we call so that is how we deal with bearing, their direction. So you talk to one line at a time, but then your value of bearing, let's say 90 degrees, 180 degrees, 120 degrees, that 90, 80, 120 is an angle. So how do you make use of the definition involving angle to qualify an understanding of bearing? We put that line, which will combine with this line for this angle to be realized, to the zero. So that is how we clear. In the concept of bearing, there are two main blocks. Two main blocks in how we call out bearing. And when I mention each of them, I'll give you an example so you can connect. There's the first group of definition for bearings, which we call whole circle bearing. It is under this system that we say that, let's say a direction is 90 degrees. A direction is 200 degrees. A direction is 250 degrees. You mention the value, but note that the interpretation is that you are reading the angle. So this line, for instance, will be giving bearing alpha when we say this one is zero or is pointing to the north. So that is whole circle. You call the angle involved in full. But whenever you deal with whole circle, this is a caveat or this is a departure point. You always have to turn clockwise from your reference meridian. You always. If you fail to turn clockwise, you are not defining the whole circle bearing. Another name for the whole circle bearing is azimuth. You put it somewhere later on when you are reading the road. Azimuth. Oh, sorry. All right. So I've explained what bearing is. I've explained what angles are. At least in a simpler method. Now, because I said in the definition of bearing, that is the angle aligned next to the reference meridian. In surveying, in science, There are three types of meridian or knobs. It's the meridian knob coming from a compass. There's a meridian that deals with the longitude, latitude, and there's also a meridian that deals with the grade system. So that is where the technical issue is. You cannot mix any north direction with any of them because it defines the type of bearing you're talking about, the type of direction. When I use a compass to determine my direction, it is not and will not always mean that when I use another method to find the direction, I have the same value. No. Because when you're doing with a compass, it depends on the magnetic north. So, what are the issues that have led this evening? In map reading, we read directions. In map reading, we deal with directions at times. We can say a forest is located north of a town. A forest is located on the northeast corridor of a town or a monument. This northeast is a bearing definition, the direction definition. And it is belonging to the second group of definitions for bearing. The first group I said is called whole circle bearing. The whole is WHOLE. And then you have circle, normal circle, CIRCLE. Whole circle bearing. The bearing is spelled this way, BEARRING. So there we don't talk of north, of south, of east. No, when you are dealing with the azimuth. So sorry, my azimuth is wrong. This one is U, it's not A. U azimuth. So when you are dealing with those circles, it is dealing with azimuth. In fact, for our map reading, this is the one we'll be using the more. The whole circle is the one we'll be using the more. Nevertheless, it is good to appreciate the other aspects. Steve, you have your hand up.
Doc.
Yes.
Doc, please, like, I don't know whether maybe my colleagues are actually following the class. It's like we are just, you know, we are taking it some way. So I don't know if perhaps there's a way, since we have six units to cover, if there's a way that we can do something about it. Because Doc, in case you want to finish the whole chapter 2 there, then perhaps it will be a bit of a problem.
I don't know where you are coming from.
Sir, please, you know.
Can somebody help him out? I don't know what they were talking about. Or that somebody understand what he's trying.
What he's saying is that maybe today you cannot finish all the unit two, so possibly the rest are tired and maybe they are not getting you. Maybe that is what he's trying to say. If we can end in somewhere a minute, it will be good. That I think that is what he's trying to say.
Henry, what is it? Amu?
Yes, sir.
Right. Henry, what did we say we were going to have our second lecture time from? It's 8 to what?
8 to 10.
Okay. In any case, I didn't say that I'm finishing unit 2. I don't know what you mean by unit 2. I already told you that the material is in 6 units and we are supposed to spread it over 4 weeks. So technically, if you are using mathematics, then you are talking about unit 1.5 for every week. But let me tell you something. These things that we are building slowly, they are even the less involving ones. How to measure bearing is going to come to you as research. But when I want to handle that, if I'm not careful, a whole 4-hour class, people will still not understand how to measure bearing on maps. When we go to contours and their landforms, when we go to cross section, they are all heavy issues and the 4 hours will not be enough. That's why I'm saying that we are made to understand that it's a facilitation. So I don't know where, in terms of the orientation, you people also are in terms of the program. I don't know your ideology. But these are some of the challenges that come. So when you take things on the face value and you want everything explained and you get everything, in the first place, you will not meet your target. In the second place, you also have challenges where you are stuck with one particular thing. You couldn't do any research to fill up, and you'll be arguing and debating the same issue. So as far as I'm concerned, it's not about finishing the unit. In fact, if you are watching the volume of issues to deal with, seriously speaking, if you are looking at volume of issues to deal with, what I've mentioned tonight is in fact, ideally, the week 1 should have cleared, if I'm doing technically my book, the week 1 should clear unit 1 and 2. That's not my aim, but that is how it is. Then week 3 and part of 4 can be cleared in week 2. Then the remaining part of the unit 4 will be cleared in week 3 because 4, 5, and 6 are heavy loads. The unit design, they are heavy loads. Cross section, when you are doing cross section, it takes a lot of time for students to come along and to get what they are doing. When you are doing bearings and how you can determine bearings with your protractor and the right, people have all sorts of difficulties in measuring angles. And so there is the accuracy aspect of what you teach about bearings, and there is what they also try to implement at their end. And at the end of the day, you are coming to do an exam. There's tolerance, there's level of this thing. So at times, if you don't learn and get the issue right, you can come and even practice and still get your answer wrong. Or you didn't do what you're supposed to do as rigidly and as meticulously. The same thing happens with cross section, where you draw your lines and you're supposed to pick your contour lines and do interpolation for the contour. It's quite heavy. So depending on the terrain, some of the contour lines are very close together. So when it gets to those things, so some of them, you'll be asked to go and do it outside and come here and then we continue the lecture. So you have not seen anything heavy yet, so this is the first lecture. But it is not a quest that I want to finish unit 2. In fact, I believe if I've been able to do that, that helps. Again, for those who were in the first session, Stephen Edu was appealing to you because I was online for almost 30 minutes and had only 20 people. So your 2 hours, you have spent 30 minutes wasted. And then now you're already tired and you want to fix the issue. So if you are not careful, there is always going to be a challenge or a difficulty between what you are supposed to get, what the program is supposed to, is looking at you receiving, how well you are also prepared to receive what you are supposed to receive, and where the knowledge gain comes in. That is how it is. All right, Steve, you had your hand up.
Doc, please. I'm very sorry. Actually, I was just trying to just I don't know, but then I'm sorry, Doc. But then say I don't know if perhaps Goblin Friday you can make time for us Goblin Friday, since Friday it's a holiday, so that we can you can wrap up things, please.
Is it your perspective or is it a class decision? And if I'm
Doc,
wrapping up, I'm wrapping up in an extra way or what? Extra time or extra I don't want to call it extra class, extra lecture or what?
Doc, please, we have scheduled a class on Friday, so perhaps maybe if you're not able to finish the unit 2, probably you can finish it on Friday, or whichever way that you do it, that will
See, you
help.
are still not getting it. See, you are still not getting it. I've not said I'm finishing unit 2. I have not said that. So don't put that in my mouth. Hello,
Okay,
those
Doc.
on the platform,
Thank you, sir.
are you listening to me?
Yes, sir.
Yes,
Yes, sir. Sir, we are listening.
Yeah, listen.
Me, I am very distant. It's one thing you have to take note of for me. I am very detailed in what I say. And I remember everything that I say. So even when we come to class and I'm teaching you, I know everything that I taught you. Whether you take it up or you don't take it up, that is your own thing. But whatever I drop out of my mouth, I know. And I'm very careful what I speak. So interpretation, I'm doing my reading interpretation, but I also do audio design interpretation. So don't twist the issues where it has not been twisted, and don't misinterpret what I say. The issue is about it's not about finishing unit 2. No. The issue is about the program and you getting yourself strategically oriented. Because you're supposed to sit in class for 4 hours. So in the 4 hours, we do what we have to do. Then when we have to leave, we leave. But then there are challenges like Steve, you observe in the afternoon when people came so late onto the platform. And what will happen is that when you come and it's 2 and 3, then you start. 2 and 3 people, then you start. In the same manner, we discuss all these things and we say we are closing at 10. And that's why I told you about strategies and discipline and planning. So please, I've not said I'm finishing unit 2. In any case, I'm doing lecture. So lecture is not hard for us. With the experience we have, we can even pop the whole thing up in 2 weeks and we are done. So it's all about you finishing off. So people will take it as we go along, but let's get the issues right and in the proper perspective before we.
Okay, sir. Thank you, sir.
All right. So that is a story. Friday. No. I'll not come on Friday. If I come on Friday, are we taking the Sunday out?
No, sir.
Hey, then we are creating timetable outside timetable. Okay. When are you meeting and who are you meeting at on Friday? What time? Lauren, who are?
Thank you, sir. Sir, I think this decision or this, yes, the proposal made by Stephen should be described by the whole class. So let's concentrate on today's class, and then after the class, whatever that will come out from our discussion will be laid out to you. Thank you.
Oh, okay. So I just wanted to see In any case, like I suggested in the early lecture today, I was saying that the Sunday one evaluation is coming out. So every lecture is important. Those who have not been joining, you may run into trouble. Maybe the rest will communicate to them. So for instance, this coming Sunday, we are going to have a morning one and then an evening one. They already be night. We are going to have a morning one and an evening one. So we are hoping to start at 9 and be done by 11. And we'll come in the evening with a 4 to 6. So note that. And I think the last time when we were discussing the issues, we laid all those things there. Just like people are struggling with the night one. Not that simple. So Sunday, I'm trying to make some sacrifice, but we cannot get all our 4 hours. So, so we treat 2 hours in the morning and treat another 2 hours in the evening, 4 to 6. And then once we end the 6th one, we are done. Is it clear?
Yes, sir.
All right. As we said the other time too, I'll get in touch with the UCT center rep. Then the issues about our material, we'll see how we pick it up. And by and large, now you are seeing what is happening. You need the material because the speed, I'm going to increase the speed for my subsequent lecture. And you need to have your support to go along with. Then there will be issues we are going to find out or we are going to research it. So let's organize ourselves better and be able to step up in terms of coordination and duration. And be okay. All right. So I will still put to the Sunday. If any discussion or you are finally done with and you want to call feedback for Friday, I can consider it. But like Lawrence said, I think it has to be thought through so that we are all on the same level and know what is happening. And, how to go forward. All right.
Okay,
Are there any
sir.
questions?
Thank you, sir.
Are there any questions?
No, please.
No questions, sir.
All right. So please read around angles and bearings. And then try to go to YouTube and look at determining or measuring bearings or bearing determination in map reading and interpretation. And look at the videos that come up because the next action probably, I don't know if it will be the Friday or the Sunday, you need to be having your math set with you. And we are going to start the process. But that one, you are going to continue on your own. And some of these things, they are examinable. I don't know how many of the past questions you've seen around, but can definitely get you some. And you see that there are times where the map work, you have to determine bearing between 2 towns or between 2 objects. Use your protractor, you use your ruler, pencil, use a construct. When you do it well, you will get your answer right. If you don't do it well, you'll miss your mark. All right. So thank you all very much. I know it's been a long day. But we still are having less than half the class. But let's see
Doc,
how. Yeah.
please, I'm done with the list, and we are about 86 in number. So I will send you the
So 86 in number divided
the
by 2 should be 43. And we are having
Yes,
around
please.
35.
So please, I will send you the file, please. Go in tomorrow.
So members, thank you so much. Take a good rest, reorganize, rethink through process, and please, the heat has begun. Don't stay on the fence. Get involved. Be active. Be committed. Put all the resources. I've told you it's only 4 weeks. One is done. Unless it's 3 more. If you're writing your exam. So see how you block issues. I'm not saying that don't do them or don't go for them. Somebody's asking about the slides. Yes, it will be put to or it will be laid in the. Yeah, I have the red page. I've been put on the red page. So the last time those who came for the meeting we discussed it. We sent to that page and then the slide. But you need to organize, get the material as well. That should help you, of course. Help you move faster. So thank you all very much once again. And good night. But let's remember, we'll keep tracking issues and follow your reps, especially if there are any messages to be given to you. It will constantly be asking, is there anything coming up? Don't wait and then surprise at some of the lectures. Or you may not have information and they ask wrongly. All right. I wish you all the best. Take good care of yourself. Until we meet again. Good night.
Good night, sir. Thank you so
Good
much.
night, sir. Thank you.
Please, can we use some few minutes to discuss the Friday time, please? Or
Okay, we are
maybe
here.
perhaps.
But you can still be on the page. I'm leaving, but you can still be on the page.
Yeah, okay, sir.
Okay, sir. Bye-bye.
Steve.
Yeah.
7.
Please don't leave, oh, please. They are leaving. Please don't leave, please.
7.
Stephen,
Yes,
we are here. Let's
sir.
decide.
Since Friday, I think Friday is holiday, right?
Yes, please.
Let's do it around 10 a.m. 10 to 12.
Please, I have an issue.
Okay, sir.
Please, honestly, this structuring of lectures outside the timetable that has been given to us by institute is causing a lot of problems. Before schedule our plans to ensure that we will use the weekends for all lectures. Now, any lectures that comes between the weekdays causes an issue. It entails or it causes for sacrifices. So, Steve, I am pleading with you. If there is something that you think you want to bring on board, let's do it outside the platform. And then after that, we will lay down to whoever that is in charge. When we discuss it, and then majority carries the vote that we all accept or agree that, let's do it. Because on Friday is 6 March. Some of us are teachers. Some of us will be assigned to take these children to March. Some of us will be assigned administrative works. So if we just go up and say, let's do it on Friday, what about those people? And besides, the Friday is not a schedule that we are trying to schedule the time. So please, let's be very cautious of those things. Thank you.
Okay, sir. So with the Friday one, it was just a proposal, and I just asked him perhaps if he will be free, he will tell us that he's free. Then we will rather discuss that and give him the time. So I didn't put it in a way that I was trying to push it to the class. No, but it was just a proposal so that if he's free, he will tell us that okay, I'll be free on Friday. Then we will rather discuss our own time and give him the time. So I didn't try doing that, but then thank you for your advice. I really appreciated that. So, and with regards to his course, it's like the course entails a lot. The book is something small, but it's like it entails a lot. So then, should we do the discussion offline? Because Lawrence, you bear with me that majority wouldn't even contribute if we are to even discuss this one on our platform. No one will talk.
Steve, you see,
Stephen, please.
we were told to wait, but you have 23 members here. Even if these 23 members contribute, we will get enough numbers to decide on this discussion. I'm exhausted, honestly, very exhausted right now. So let's do it on our platform, maybe tomorrow. Then after that, we finalize it. Thank you.
Okay, all right.
Please, can I make a suggestion before we discuss it on our platform?
Oh, yes, yes.
All right.
When
So on
are you
Friday,
meeting
it
on the
seems we
platform
are
to
going to be
discuss it?
having 2 lectures.
We haven't agreed on this one, so this one isn't part.
Okay. So suppose this one goes through, it means we will have the methods of teaching and then map reading and interpretation.
Yes, please. That's for us. Geography major.
Major. Okay. Please, if it will not worry the rest of us, I'm suggesting maybe we can have 2 hours in the morning, maybe 7 to 9. Then those who are going for the 6 March can go and attend to that business, and then in the late afternoon or evening, you have another lecture. It's just a suggestion. So it's just a suggestion from my end. Thank you.
Okay. So please, let's discuss that with our members on our various platforms.
Okay then. Then good night.